New topic for this afternoon session is called inheritance and encapsulation. And I actually already touched these concepts in previous session because we need to do something like iterative approach and bootstrapping, because these are related concepts and you cannot describe them into empty space, you need to link them to there. But I will tell you more details about inheritance, access modifiers, overloading and overriding, composition and encapsulation, this and supper or constructors, instance of and get class method, packages and wrapper classes. So inheritance is thing when one class is based on another class using the same properties and methods, and it may be adjusting or specifying method implementations and properties. And reason for inheritance is to make your design cleaner, to save your effort and make it more maintainable and to remove duplicated code. In this picture here we see Java code on left part and class diagram on right part, UML class diagram. We will talk in details about this later. And we see here that here are quite a lot of similarities or even duplications between class employee and class manager. And we can avoid these duplications to put similarities or similar things only in one class and then extend it on the other class, and our code becomes much shorter. That is good and much more maintainable, because one of features of good software design is that if one single requirement changes, you need to implement and change it only in one single place in your code. And if one single change in requirements affects many places in your code, then that means you have too much of redundancies and duplication in your code, and it should be improved, probably with inheritance. And because these ideas came together from many different places, therefore the same thing may be called in a little bit different term, maybe with different focus on important features, but class which is inherited may be also called extended class or parent class or base class or general class or superclass, and class which inherits something and extends this previous class may be called extending or child class or derived class or more special class or subclass. Going up in hierarchy is called generalization, so you generalize things when you go from specific things to more general things. And going down in hierarchy means specialization. And hierarchy means that, for example, in UML class diagrams, usually more general or parent classes are shown on top of picture and more specific classes on bottom. So when you do generalization, you go up. When you do specialization, you go down. And here is example of class diagram with inheritance. So more general classes are up, more specific classes are down. And because in Java you can extend only one class, inheritance is always 3. There may be one parent with many childs, but each of child has only one single parent, and therefore this inheritance shows tree-like structure. Access modifiers are keywords you add before signatures or declaration of your methods, before declaration of your variables. And what is meaning? First, there is one meaning where you do not have access modifier at all. What does it mean? That means that this particular method or property will be reachable from the current class or from other classes located in the same package. If you add public keyword, then it can be reached from everywhere, and if you add a private modifier, you can reach this method or property only from the current class. So if you are doing it inside body of current class, these are reachable, everywhere else it is hidden. And then regarding to extension, there is access modifier called protected, and you can reach properties and methods either from current class or from current package or maybe different package, but with subclass which extends this class. So protected means that everybody who is in the same package or which is a child of this class may reach these properties or methods. And then when you extend something, usually if you do it properly according to the object-oriented approach, you add complexity, and one thing for added complexity is that inherited methods may become more complicated ones, and this process is called method overriding. So if you extend employee to manager, you already got the implementation of getDetails method, and if you are happy with this, you just use it. But if you are not happy with this, you need some added complexity, you may override it and you may say something like more complicated structure here. And you shouldn't confuse two similarly sounding terms like overloading and overriding. Overloading is not about inheritance, it's about many methods with the same name. And in this case we have many methods setMyObject, but these are overloaded methods because these are not absolutely the same. In one case it doesn't take parameters, doesn't return anything. In other case it doesn't take any parameters but return boolean value. And in third case it takes integer as a parameter and returns object as a return. So these are overloaded methods, and you use them, for example, when you need to pass different kind of arguments to these methods, then you can choose one particular implementation. But overriding means that when you extend some class, for example, you have myObject class and then you extend myObject to another object, and you say void setMyObject, do something else here. So that would be overriding. And when you add some complexity, you are encouraged to use super keyword quite a lot. And super keyword can be used in two different ways. So I have one simple class. It will be like a library, no main method at all. And when I extend it, remember that constructors are not inherited, and if I want my, this constructor should do something. He is you use super keyword to refer to parent constructor with opening brackets, but for methods it's a little bit different. For constructors super and opening brackets, for methods super dot, and then either properties if you like or brackets. And this is how it works. And so here, with the super keyword, you may make this code even shorter, because here you have still some duplication for this overridden method. But if you just need to add some complexity, you can do most of things with method inherited from parent class, and then do just some adjustments after that. And then, when you do inheritance, you can use polymorphism quite a lot. Let's say in this case super should be before that. Okay, let's make it. And then you can do something like or so here I use this polymorphism in this very small example. I have created array of test objects, but in particular cell for this array, in one case I create actually test object, but in other case I add test1 object, which is more specific case of the test. But I still can process them using the same method. And hopefully something, print line. Print. Maybe something like this. So here it's called from test1, where we start with test1, and then we use just a test. somewhere here probably. Something like this. And here is another example, for example, where we override a method, for example, get details for some object. Similarly, we all can use polymorphism to pass arguments to the method instead of overriding something with many different subtypes of parameter. We can generalize this type and we can say here let's make it more complicated. Oh, I don't know. And when we call this method, oh, how I called it, M2. I need to override the string method. I will not override, I will say here not test, and we see that here I again used this polymorphism principle that in one case test object was passed as a parameter to this method, but in another case test1 object was passed as a parameter, but because they both are test objects, only in one case it's more specialized test object, we can use the same parameter here to pass with type just test, even though specific type is test in one case and test1 in another case. And so virtual methods are methods where exact behavior will depend on specific type of object, and in this case I made this to string method virtual because here I get type of object dynamically, and if its type is test, it returns following string class test, but if actual type is test1, it returns test1. So this is now virtual method because its actual behavior will be different depending on specific type. And of course I can do it a little bit different way. I can say, for example, test in this case, and test1 in this case, then it still will be virtual method, only implementation will be a little bit worse, because now I have more code. Here I just called get class method dynamically, but now I have 4 lines of code here, 4 lines of code here. Everything is the same except this literal value here and this literal value here. So now I have some more code in short and more duplication. So when you override some methods, then rules may be hard to remember, but every time you deal with inputs and outputs or whatever, you should remember data flow principle. For example, we have method, and here is int e, and it returns string. So syntax of Java is inherited from C, and what is input? It's actually last thing here. This is input for this method, and this is actually output. And you should remember that every time you talk about input and output, this funnel principle, Piltuvä, that in this case input is int e and output is string. And when you inherit something, nothing bad will happen if your input will be bigger and your output will be smaller, like long e as an input, which is larger than this. So input will be just subtype for that, so on here you extend. And output should be more specific. Doesn't look great for string. Let's make it object. And then you return string. And this is what you need to remember. Every time you pass some data, return some data, and you extend it or implement, which we'll talk about tomorrow, bigger inputs and smaller outputs will be always okay. And that's how I think you should properly remember. For example, and also access modifier. Access modifier is also input. For example, if your access modifier is private, this means how can you reach this method, and private means only from the code current class, and if you extend it and make it protected, you actually widen the scope of access to this method and it will be okay. But if you will change protected to private, then I think you immediately will get compilation error, and if not, then runtime error. And when you deal with polymorphism, sometimes you need to know what is concrete instance of this object. For example, you have a method which has quite general input parameter, employee, but employee may be extended to manager, which may be extended to engineer. Then sometimes you need to check, is this what you look here? And this employee, now here is generalization. And how does it work in details? In details it works following. For example, you have class, let's say employee. And you have name for employee, let's say it's string. For manager, string department. And for engineer, I do not know, degree. And you create new employee. Blah 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 is new employee. So with declaration you create its reference, which is null, and with new employee you create actual data structure. That means you say it is employee object, it will refer to this class, and you can get the reference to this class using getClass method. And then from this you will see that there is string inside it. So somewhere here you also should have the definition of string class, and you see what's inside string. So here it will say I'm string, And here it will say I'm array, so which means you have also array class should be loaded of, I do not know, 4 bytes. And this is your actual data. And then this reference refers to beginning of all these data structures. And if this address is 123, then this reference will be 123. If you create engineer, or let's say manager, again you will create reference for it and everything will be similar, but at the end of this manager, so this will tell not that it is not employee but it is manager, and manager extends employee. It will also have string for department, and from this you refer to manager, and you know how to read all these data structures. There should be string showing name and string showing department. And what happens if you upcast manager to employee? You say that what is manager here is actually employee, and you return definition of data structures for employee. And what do? You read only so many data structures as data structures for employee are described, and you ignore everything what is here. But if you cast it back from employee to manager, strange color, then you read here and you see, here some more data are actually needed to get the name of department as a string. So when you cast objects, you never copy data from one place to another. What you actually do, you just change instructions, what kind of data you need to read. And again, remember that in proper approach you always add complexity. If you remove complexity and you make something hidden here, then only thing you will have probably empty data structure somewhere here, which will not be reachable, but you will just jump to here and read something else here. If you decide to do so that you actually encapsulate some internal complexities, these data structures will still be there, but they will not be reachable using instructions about this particular class. So with instance of, you can actually check what is actual instance of this upcasted or generalized passed argument. So if this employee is actually manager, you can handle as a manager. If this employee is actually engineer, you handle it as an engineer, or handle it something else. You can do it in 2 different ways: instance of keyword or get class method. Instance of keyword will return true. Yeah, ask your question. You never lose information if you upcast, but what you lose instructions, what kind of data you need to read. Yeah. If it's actually manager, because employee may also be engineer, but if it is actually manager, then you will reach instructions and will reach a possibility to get additional data structures, additional methods, whatever this more specific class has more general type. But we will see this also in our practical exercise as well. An instance of keyword returns true if particular type is either this particular type or any extended subtype of this. So that means when you use instance of, you always start checking with more specific type and then finish with more general type. But if you use getClass method of course refers the reference to one exact specific class, what it is, and then of course everything else will be something different. And getClass refers you a reference which you can always convert implicitly just a primitive type like a number, and you can, for example, compare getClass with definition of the class. I will show. You can do. Okay, we can do some bad design here, something like this. If not here. I will show it later. We will go ahead. So casting reference types, again, generalization is always working, specialization may not work, because when you generalize things, for example, any test and test1 object is also test object, but if you have other class which extends test, then of course there may be some instances or some objects in jargon which are also test, but which are not test1 because they are test2. And therefore for downcasting you always need to check is it instance of, for example, and then you do something if instance of is true. And when you overload methods, for example, one of things is what you need to check is, for example, more specific type. For example, if you pass argument as a string or as an object, you will not be able to distinguish between string and object because string is object and object is an object. So there are some limits how you can overload different methods with, for example, distinguish with unique types passed to it. And for example, float and double can create confusion because for primitive types only thing you can check is size of them, and float is floating point number, double is double length integer, but because length of them is the same, you cannot distinguish between them in runtime. And similarly, for example, you cannot distinguish between string and object because string is object and object is an object. And when you overload constructors, again, you can do many different parameters, but you should be careful sometimes about precise types because these should be unique enough so that they can be distinguished. And one of things what you do, for example, with different set of constructors, you use this keyword quite a lot. And here again, this example shows you quite nicely that this keyword can be used in two different ways. One is to refer to current object, this dot something, and this opened bracket means referring to different constructor. And as I told you, constructors are not inherited. If you want to inherit them, you create your new constructor and just call super with or without parameters. And here is constructor example with overloading, and here is with extensions. So here we have several constructors, and when we extend employee to manager, we need to write additional constructors. If we don't need anything to change, we just call super, But if we need to add something, we start with super and then we do additional things. And I will show it in practical exercise. If you have your constructor and you do not have anything inside it at all, it means it implicitly calls super without arguments. And if there is no such constructor without arguments, you will get compilation error. And I already told you what is need for encapsulation. Need for encapsulation appears every time when direct access to your data structures may introduce wrong values for data. For example, if you need to create simple calendar, you use integer numbers to count days, months and years. And if they are not encapsulated, so they are not made private or at least protected, then everybody who is not lazy may set negative numbers to it some years in the future, which maybe you are not wanting to allow, etc. So you make them private and then you make setters for them to check these rules. And because you cannot get value back for them as well, then you also need to create getters because of that. Getters tend to be simple if you don't need to have logging. For example, to log every time somebody is accessing this data, then for getters you just return data. Sometimes you need to create new instance of these objects. We will talk about this later, but so this is one need of encapsulation. Other need of encapsulation is more complicated cases where you can't exactly decide how to implement something. And here is one case how you can see, even though practicalities are very different, but from business perspective, inheritance and composition may be exchangeable. It's something like, I do not know, you can eat cake and you can eat soap. Completely different things, but if you just need to get calories, you can exchange one with another. And similarly, inheritance is something completely different. Inheritance means something is more specific type of something else, but composition means something is inside something completely different. And in your practical exercise here, for example here, traffic management system is neither transports nor roads, but it has transports and roads inside it. So my arm and my leg is not me, but my arm and my leg is part of me, but I may be human and manager, etc. And here is example in real world. You have Coke machine, which allows you to get drink called Coke and orange juice. And if you extend it, it still is the same thing, Coke machine, but you add some advanced feature. And in this case, you get mix of both juices here together. So it's still Coke machine, but with more extended features. So in this case, this machine extends that machine. But you may do composition and you may create completely new box, which is not considered this Coke machine. It's something completely different. Vending machine. And you put this Coke machine inside it as a part of it. And then also add this mix of Coke and orange juice as the only thing available to it. And if this is only thing available to it, you are also encapsulating it. You are not showing that this completely new machine actually is the same old machine wrapped up and put into something completely new here. And when you use this approach that you create something completely new and hide dirty details of implementation. Typical example is that in your business requirements, might tell you quite frequently that something is many things at once, and scientists have proven that similarly to computers, also humans do not actually do actual multitasking. If you look on lifeline during time, what you are doing, if we say that we are doing something concurrently, what we are actually doing, we switch from time to time to complete one task and from time to time to complete other task. But if these switches becomes quite regularly and they blur together, you can generalize. So this is actual thing, but general thing maybe that I can do red task and blue task concurrently in parallel, even though actually I am just switching from one task to other to do. This is how computers work, this is how actually humans work. And this may cause you a problem if something says in your requirement that something is both at the same time. For example, teacher and student, child and parent. For example, I am teacher to you, but I am student to some other teachers. I am parent to my child, but I am child to my parents. And in general, in UML and in business requirements, it is completely legal to say that there is things called amphibious, which are both sharks and humans at once. But you cannot implement it into most of real programming languages, because if it has move method, then compiler cannot decide how this amphibious should move, because there are two conflicting movements. Shark swims in water, human walks on ground, at least most of the time. So therefore this is not allowed, and what you can do about this? You can use composition as a substitute for multiple inheritance. Instead of extending both sharks and humans, you create completely different animal, amphibia, which has shark part inside it and human part inside it. Like Ichthyander, this old Soviet movie, made on basis of older Soviet book. And then you make, if you do not encapsulate them, then everybody will see that your amphibia actually is some Frankenstein monster containing shark and human inside it. But if you make, and then you do something like this, that without encapsulation, you can create amphibia, and you say amphibia.human part move on ground, amphibia.shark part move on inside water, in water. But if you encapsulate them, you just expose this move method, and you say something like move on ground, move on water, and it uses shark part to move in water, human part to move or walk on ground. And this happens quite a lot in system design, that every time you need to do something like multiple inheritance, what you actually do, you put different parts together. You will see that there is still some drawbacks and maybe some catches there, but that's what you do in general. And also in your practical exercise, what you will need to know is about packages. So far we always worked in the same package, so we didn't care much about packages even though we were using it, because here you see that all these classes are in package gtm.activity04. I showed you in this example earlier that if you do not have packages at all, you can still import and rely on any other class inside package, but you cannot use, for example, if you create new package, then you cannot refer to these classes from packages anymore, because this is considered unsafe, because classes without packages may create library hell, because then these names may not be unique enough. And that means every time I create some package, what I actually need to do, I have to have, for example, now here, I cannot just say, okay, as a variable, this is now that class, okay, test1. So it cannot be resolved to a type, but if this test1 is in this package, then it is resolved, because then I have compilation. So everything should be put into packages. So you say in which particular package your class is, and if you need to get packages, classes from other packages, you say from which particular package you will import them. And these imports should be in general globally unique, and if these are globally unique, you will never have this library problem to understand which library is actually used. So you declare in which package your class is, and then you say what things you need to import, and we will do this in your practical exercise as well. So and here are these rules. So if you use only default package, you can still import anything you like, but if you want to import this package, it always have to be put into some other package as well. So this is by design to make system integration much more robust and predictable and consistent. And to be sure that these packages and full class path. What is full class path? Full class path is name of the package together with the class. So simple class name is test1 or test here, but full class path is test.test. And I can always just write test.test in such a way. So this is full class path of this test class here. Package plus name of the class. And just reminder, names of packages by convention should be only lowercase letters, and names of class should start with capital letter. And if you work in commercial entity, because domain name system is globally unique, you tend to use domain name system of your companies to be sure that these packages are globally unique. So that is about more details about all these types. And actually I think wrapper classes are moved to something else. I think I will tell about this tomorrow. So, any questions or comments on this?